Welcome to the session on LoRa, whichever way you'd like to pronounce it. I was asked to moderate this group, but it's a group that doesn't really need moderating at all. All great partners of ours and self-starters. So, but let me introduce you. We've got Tim van Dam from Smart Parks, Colette Terblanche from Peace Parks, Jordi van Oort from African Parks, Sophie Maxwell from Connected Conservation, and Swabir Abdulrehman from 51 Degrees. So they're going to start with some presentations in that sequence. Then we can open the floor to some questions. Tim?
Yeah, thanks, Bruce. So just to be open, we're not going to into technical details. So if you want to have technical questions, then we can answer that all together afterwards. So it's going to be more an overview of where we are with LoRaWAN, and we want to showcase that we are all using it, and we're all trying to share knowledge on it so that it will be utilized better for conservation. So that is the main thing. Just to give you an overview what LoRaWAN is in the context of conservation, there's a little bit of a video. There's the Smart Parks logo on it, but you can just forget about that. It's just about the concept, like where it's used for. So can you please play the video? Well, it's not there. No. Okay. I don't think there's going to be a video. So I'm trying to explain what it is. So LoRaWAN is an acronym, obviously, but it's a communication standard, a protocol, essentially to facilitate connecting devices, sensors, so that data can flow into applications like EarthRanger. And LoRaWAN stands for a low-power wide area network, meaning it can connect devices, sensors over a vast remote areas where there is maybe no other connectivity like cell phone connectivity. And that's why LoRaWAN is there for 8 years now. It has been introduced in Tanzania actually for the first time in conservation, especially for rhino tracking. After that, the past 8 years we have seen a tremendous growth in the use of LoRaWAN. Not only in conservation, obviously, but in all industries across the globe, and it's the main standard for Internet of Things. So it's maturing, and that's why you see a lot of us using it, and now we are in a place of sharing knowledge about the use of it. Just to show you a couple of applications where it's being used for, so wildlife protection, obviously, to track all kinds of animals with collars and other means. Park management, for example, tracking your assets, your graders, your rangers, have you not? For example, also like water sensors and rainfall sensors. Community conservation is another one where the community around and in the park is protected areas are also involved. Obviously, they can also be using this technology, and tourist safety is another very important one. Yeah, I want to give the microphone to you, Colette, so you can explain a little bit more about where it's being used currently.
Great, thanks, Tim. So LoRaWAN in conservation is not only used in these areas, which I'll go through, but these are the areas which we are aware of. And so a lot of it's being used in Africa, quite a lot in South Africa, Kenya, Mozambique, Namibia, Zambia, a few countries in Africa. And then what we're aware of, and this is specifically where it's being used in conservation. Now we know it's being used in a lot of cities and other places, and in Europe, quite a few places also where it's being used, as well as other areas too. We also listed, there's a couple of upcoming parks that are being, LoRaWAN networks are being developed, which is in Chobe, Botswana, Masai Mara in Kenya, Simalaha, Community Conservancy in Zambia, and then as well as Maputo National Park in Mozambique. We also added some Sigfox because it's pretty similar, and there's quite a couple of, and I'll explain to you now why we added it too. But basically, just to kind of to show you a bit of an image of some of these areas in conservation that we are aware of, that is being used, LoRaWAN is being used. And if you are aware of any other sites or you're using it too, please let us know. It'd be nice to add it to the map. But there has been quite a few, oops, that slide has changed a little bit, but there has been quite a few talks over the last couple of years between different users in conservation using LoRaWAN and trying to learn from each other, because we all have made a lot of mistakes and a lot of things have changed over the last couple of years of new technology coming in. So yeah, after a good couple of conversations with a few people and sharing a lot of knowledge, we decided to have a workshop on the 27th of July this year. And the amount of interest has been incredible. I think I sent it out to about 30 people, the invitations, and asked them to send it on to other people. And there were eventually over 80 people who we eventually about 66 people participated either online or attended the workshop, and then there was about 18 people who couldn't attend and asked for a lot of the information to be sent, and a lot of other people who really want to know more. So if you are interested, let us know, and I'll explain to you now why too. But basically what came out of the workshop is to start sharing knowledge on how do you put LoRaWAN networks in, what kind of equipment have you used, what kind of problems have you been experiencing, and what kind of came out of it was looking at firstly at the network servers being used. Mostly ChirpStack was being used as a server, and obviously there's a lot of other ones being used too. And obviously this was just from the people who attended the workshop and actually presented. So there might be, if you had to really ask every single person that participated, might change a little bit. And maybe there's more people using another server. But in terms of LoRaWAN gateways, the most used one was curling from the workshop. But obviously, there's a lot of other products, and people have been using Cisco, MikroTik, UV Space also. So, so if you have or would like to participate or give information out on us, let us know. Let us, be in contact. And then LoRaWAN server hosting, most of it, it found through the workshop that half of them were self-hosted and half of them were done by third party, which was quite interesting, and how people or different parks are connecting. Network connectivity was also more parks are using a backhaul links or networks and less on GSM. Obviously, I think I think Jordi made a comment also that if you had to look at all the African parks, and maybe there's be more GSM. So you have to look at it just in the workshop context from this slide. And then data viewer, out of what came out of the workshop, that more people were using EarthRanger and not so many CMOR anymore. And again, this was just from workshop findings, but so CMOR is a platform done by all the South African government parks have to use CMOR, but more and more of them are using both CMOR and EarthRanger now. Okay, some of the lessons shared out of the workshop, which was quite interesting and really particularly to this workshop also, was that people found that it is best to start standardizing your equipment. So in other words, if you have it in a park, try and use, or you're managing a few different parks, try and standardize what you're using. So standardize the type of gateways you're using so that all your towers eventually look very similar. So you can send someone out there and say, okay, just go and change this, and it all looks very similar, and it makes it just easier for people not so technical or your management team to go and help to. Maintenance. This is a critical point that people brought up, and then funding to continually maintain these networks have to be budgeted in, and then manpower. A lot of us probably have a similar problem where your parks are quite far out and remote, and then to find someone to actually go to that tower, which is also remote in that park, and go and change something there is a problem, and that needs to be factored in. and yeah, training is very important. So remote monitoring systems do help. That's what also came out, and to monitor the power on the tower as well as the network on the tower is critical. And then it requires integration into park management operations. So this is really important because you can have a brilliant system, but if it's not integrated into the way the park operates, in other words, you have to have, if you have a lot of LoRa sensors, how are they being used? And are they really making a difference in terms of the park operations, and it has to be part of management operations to maintain these technical systems being implemented. And then the last one was so the support required to integrate and manage different sensors and monitor the performance is an ongoing thing. You need to once integrate your sensors into the LoRa network and then monitor continuously for how they're performing, do they need to change, what other ones are better on the market, and that was also very important. Okay, that's all from me. We'll carry on.
Thank you. Yeah, just some more lessons learned. Basically going on with what Colette mentioned from the lessons learned within African parks, trying to deploy and maintain LoRa systems in about 8 parks now. I think the first real thing that we need to all think about is what do we need? What are the crucial areas? Where do you want LoRa coverage? Because in a lot of places you're not going to get LoRa coverage everywhere in terms of the topography. This is Majetti. You can see that with the towers there, there's still going to be a lot of gaps in some of the fence lines in the south and in the west. Confirmation on the ground is extremely important. That goes down to the people on the ground. So in terms of where you're going to build your towers, these things are all planned on computers, but you have to have your people on the ground or go there yourself to check if that is actually possible or not. Trees, for instance, might be much higher than you think in terms of a planning tool. Hardware, that goes down to what Colette says as well. You all need to think about what you're going to use and standardize that as much as possible. We always say that we might not actually be using the best possible hardware out there, but we need to be able to actually transfer that knowledge to our people on the ground to make sure that we can keep things going. So once you made a choice, you can't keep continuously changing it if you're spreading across a bigger area. One thing that's extremely important is the actual backbone. Like Colette said, we don't have GSM in most of our areas. So all of these LoRa systems depend on the connectedness of backbones. If one tower goes down, for instance, if Majetti Hill in this picture goes down, you're going to have no network at Mpemba either. So the network is usually more difficult to maintain than the actual LoRa system, because that just usually works. But if the dish doesn't go down, the data doesn't get back. Gateway types is what we talked about. The skills are extremely important, and I think it's something that we need to really focus on as a community. Most of the hardware and in terms of keeping things going is not usually difficult, but we need to also understand what is needed. We need to understand what people know, what they don't know, and where that knowledge is required. And that's then going into the knowledge transfer. Deploying, we've been deploying quite a lot. Swabir, a lot of these pictures are also yours. They also have deployed a lot of these sites. Lots of our towers are self-built. You need to really think about safety here and about the maintenance of these things. We've had a lot of towers in the past that were little like flag post systems. So you put a little post and you raise it up, but then you actually realize when the dish goes down, you can't actually get there. So it's a big learning process. We're using a lot more towers that are more like the bottom left here now, so you can climb them. In a lot of countries, you have contractors that build telecom towers that can actually do these things as well. Usually more expensive, but in terms of safety, we need the right equipment, you need the harness, you need to make sure that all of your colleagues are safe when they're climbing these things. And it's all things to take into account when you're actually building a site, because that might be more expensive right now, but in the long run, it's going to really help you if you have a tower that you can actually climb. Where to start with the planning? I mean, equipment housing is another one that is extremely important, and I think the next slide in terms of maintaining is going to show you that a little bit more. And then future needs. What I was hoping to achieve with that one is that there are multiple ways to build a LoRa system. In the past, for instance, in Akagera, where we've built it in Liwonde, you've had the whole park covered. Majetti is the same. In other parks, we've tried more of an organic approach where you start adding LoRa to the radio towers, and then you try to find out where your black spots might be, and then you keep adding some LoRa gateways in the middle to try and get rid of those gaps. So in terms of maintaining, this is the whole standardization that we've been trying to do. As with most people here, I think we have our own power solution, completely standardized equipment. I'm happy to share as well. What we have realized is that housing-wise is really important, is the size of it. Don't make it too small, because you want to actually be able to take out a piece of equipment and replace it if needed. Plug and play is very important for us, because that means that we can train the people on the ground. When you plug in the system, it works. Maybe it's already pre-configured, maybe not. Monitoring is actually way more important than we ever thought. Basically, it actually shows us the problems before they become problems. Are your batteries still holding the power? What's happening with the sun? I'm checking these kind of systems every day, where you can actually just tell the guys in the park, I think there's a tree over your solar panel on this side, please go there. And usually you can see, there is a tree there, so they can cut it. So basically a lot of monitoring helps us a lot in keeping things up and going. Bearing in mind that LoRa is the same as any other technology. If you keep losing power at these kind of sites, some of the computers in either a dish or in a gateway, or maybe not if you have a better gateway, but when you start unplugging things, something might break or will break. Remote access is important for us. A quick one I thought about this morning, Tim, is when we started and you told me, hey, the gateway in Kakakera North is down, I would go in my car and I'll drive 3 hours and take the thing out and just wait for 10 seconds and plug it back in. We can do that from South Africa now, or from the Netherlands, or these kind of things are really helpful. Knowledge transfer is really important, and I think as a whole community, with technology and especially with these kind of systems coming more and more in play, we need to make sure that we invest in good people on the ground. We invest in their skills. We invest in the knowledge transfer and the knowledge exchange. And we make sure that these kind of technology positions in the parks become proper positions. Otherwise, people will keep leaving your parks, and then it's just difficult to maintain systems if the people keep going. Over to your case study.
Thanks a lot. Hi, everyone. So Swabir and I are going to talk about a collaborative case study for Northern Rangelands Trust in Kenya, which has really relied on a huge amount of effort from many people on the panel, many people in the background to make this a possibility. It's really been a collaboration between public and private partnership to develop one of the largest LoRa networks in Africa for conservation. And so I work at Connected Conservation Foundation, and we bring together different partners for use of their technology resources, donors and supporters. So we have to say that we're very grateful for all the support of the people at the bottom of this slide. Any technology project needs help from many partners. So from Cisco to Dimension Data, Actility, Smart Parks, everyone has really come together to make this a possibility. So moving to the next slide, this is a picture of Northern Rangelands Trust JOC. But before I go on, actually, I just want to tell you a little bit about Northern Rangelands Trust and the neighbouring reserves, Lewa, Oljogi, Loisaba and Barana. So for those of you who don't know, NRT, Northern Rangelands Trust, is a huge area. It's a climate-stressed area of 63,000 square kilometres. It's home to a variety of threatened species, huge array, and also 100,000 households. So over the recent years, it's really been experiencing severe drought, and this has put huge pressure on grasslands, water, and food for both communities and wildlife. So it's been really important to closely monitor the movement of wildlife across the region, the movement of pastoral communities, and environmental factors so that everybody can coexist and secure the kind of lives of species and livelihoods as well. So it's really this project, through technology, enabled the peacekeeping teams and the rangers to work together to improve the efficient use of their resources and collaboration between everyone to rise to these challenges that I just mentioned, so they can involve sustainable land use practices, tackle human-wildlife conflict, tackle conflict between communities, and also keep security going for all the species. So over 200 sensors are now deployed across this entire region. And as I mentioned before, this is a picture of NRT's JOC, whereby we have a screen for each of the conservancies. And behind this picture is actually another room with another screen for NRT's conservancies. So the network is across 22 of NRT's conservancies, as well as the private reserves. And one of the really unique things about this project is that we've been able to join those reserves together. So assets can actually roam across private reserves as well as the community-led conservancies. And everybody knows that species just don't stay in one private reserve. You need to be able to monitor them across neighbouring reserves. And this has really been possible through, a huge amount of collaboration and the enabling the ability through the system for those reserves to actually choose which data they share with everyone and choose which data they share, they keep to themselves privately. So this has really helped with collaboration. So we've actually been blown away by the huge diversity of use cases that have been onboarded and the many sensors, as I mentioned, 200 sensors that are now being deployed and tested. From the security side of things, the team with Swabir have ranger trackers deployed and they're monitoring patrols. So looking at the routes of the patrols, keeping the rangers safe, vehicle tracking, and then fence sensors as well to understand when fences have been damaged or there might be a possible incursion. Rangers, have deployed rhino trackers. So this is super useful because the rhinos can then wander between conservancies and we can really take down fences and increase the rangelands for the rhinos. Predator sensors have been deployed, so you can also get an early warning of when predators are coming near communities to prevent human-wildlife conflict. And really a new use case is livestock tracking. So cattle trackers on herds are enabling the rotational grazing management of grazing resources, so there's enough for species and for communities, and it can be managed sustainably. Environmental sensors are really important. This is such a big area. You need to know when rainfall is localized to a particular space in drought conditions. So rainfall gauges, water sensors for watering holes, river flow gauges. This all helps manage water for communities and species. And resource tracking, diesel tank monitors, sending information over huge distances so we can efficiently do this. And all of this is then able to ladder up into monitoring and evaluation so that you can look at historical data to verify conservation implementation projects. And one of the key successes to this project is really the reusability and configurability of sensors. So it kind of works like a library concept, whereby once one sensor is onboarded for one conservancy, that's available to all the others, so that they can reuse. So whether they're onboarding a smart park sensor, Chinese sensor, one animal tracking sensor for African trackers or whatever, that is easy to onboard and propagate the information to EarthRanger. And so that configurability of those sensors has been really key to make sure only the really relevant data gets through to EarthRanger. LoRa sensors send a lot of information. It can drown you in data, so it's really important just to make sure that the real important insights and alerts are coming through. Swabir's team have done a fantastic job keeping a technology registrar of all the different sensors through an R&D process of what's been tried, the cost of those sensors, and what's working for which contexts. And that's been shared with all the conservancies. And I think Swabir and the 51 Degree team have been really playing that central champion role of integrating everything between the conservancies. Technology without people doesn't work. And so we are really grateful to Swabir and the team, the administrator of administrators, Swabir. Over to you. How does it all work?
Thank you, Sophie. Let's see what's next. Okay. Hi, I'm Swabir. I'm going to take you on a little journey of starting all of this. So about just over a year ago, I actually called Tim and said, "Hey, Tim, what's LoRa?" And And he proceeded to explain to me very quickly over the phone, because he had another meeting, what LoRa was. And that's when this project was landed on my desk, and I was told that we were going to roll LoRa out for NRT. And so we looked at the project, we looked at the equipment, and we went through all the lists, and then it seemed like other conservancies wanted to come in, and LoRaWAN was one of them, Barana, Losaba, and Old Jogi. So the scope was growing of the project, and it started to become a little bit more complicated. You know, there's landscape politics that starts to play a role. There's knowledge, of which we had none at the time. It's all Cisco equipment, which is known for being very easy to use. Not. So I had to go and learn a lot. I had a lot of late nights reading about this stuff, a lot of nights worrying about how this project was going to come together. We have multiple people in the room who have assisted on this project. Martin from NRT, we have Morris from LoRa, we have Llewellyn from Barana. You know, all of these people were instrumental in fabricating the masts, making sure that their sites were prepared, making sure the logistics were in place. You know, all of these things that are the things that go unnoticed by people, but are fundamental to making this thing work. Without these champions in all of those locations, you know, I wouldn't be able to do my job, and the system would fall over tomorrow. You know, if I get online now and notice that a gateway is down, I know the person that I can call who is the champion in that location, who will go to site and will tell me what the problems are and inspect it and help me get it back online quickly. Without that, totally useless. You know, it would take me 5-6 days to get to that site if I really needed to get to that site. So we must not forget that those people are instrumental to making this thing work. And if you are, you know, an African Parks, a Smart Parks, people who are putting LoRa networks in multiple different locations, we need that one person. And we need them to stay. You know, we don't want to train them up and teach them everything and then for them to move on in a couple of months' time. So that's really important. The next one that was really important was finding sensors. LoRaWAN, you know, I've got an inventory of about 600 sensors in my inbox from multiple different suppliers, from China to Europe to America, all making 868, exactly what we need in Africa, LoRaWAN sensors. So how do you find the one that's fit for purpose for us? The answer to that question is really difficult. So what we've had to do is buy multiple sensors. This landscape that we've talked about has started to talk about putting an R&D fund together where we will put a pot of money together, and that money will facilitate somebody to go to a LoRaWAN roadshow and learn more about LoRaWAN. We'll facilitate buying more sensors so we can test. You know, we'll facilitate making our own sensors if we have to. So that ability to R&D, test, move on, R&D, test, move on is really important. And without it, really, we're not going to develop as a community. So the last year has been really important in terms of buying sensors, testing them, developing a register of tested sensors proven over time. Yeah? And that, you know, in itself is worth gold. And now we're linking together as multiple agencies. That's going to grow a lot faster, and I hope that it does and perpetuates that movement. In terms of the NRT network, it's multiple sites. You can see the NRT side is the biggest side of the network. It goes all the way from northern Kenya down to central Kenya. And then we have Old Jogi, which is a bolt-on separate network, Losaba, which is a bolt-on separate network, LoRa, which is also a bolt-on separate network. And now into this, there's 4 other separate locations looking at coming in, Masai Mara being one of them. And all of these separate locations will also bolt onto this network. So what we've done here effectively is given the ability for Kenya, for anybody in Kenya to bolt into this network and eventually to have a Kenya-wide conservation network being managed through a central server. So anybody in Kenya who's working in conservation effectively could be working through this single server, and those sensors in that single server can go through anywhere in the landscape, use any of the gateways, just like your mobile phone would do, working on a single Safaricom or MTN or Airtel or whoever your facilitator is. So as a collective, this is what we were saying. We're trying to create a structure and a process to facilitate knowledge sharing between users and providers of LoRaWAN-based solutions for conservation. Online knowledge sharing, network of contact persons, meetings, workshops, and training, and a network of early collaborators as such seen on the stage. So we're trying to build a community here around LoRaWAN users. We've called it LoRaWAN for Conservation, LFC. I'm not sure that's the official name, but so we would like more people to be part of the LFC. We would like to enhance our knowledge sharing. We would like to enhance our learning as a community. We'd like to grow a lot quicker, and we'd like all of you to be part of that if LoRaWAN is where you're going in the future. Thank you very much.
Thanks very much, everybody. I think that requires a round of applause, please. Thanks. I often get asked questions by sites that are new to EarthRanger, new to a lot of the technology, and it's taking a bit of a step down to the broader NRT Kenya-wide type of environment where there are a lot of connected areas. So I have a couple of questions for you, please. The first is, and it's a how long is a piece of string type of question, and that is how many sensors, how many gateways do you need in an area? So maybe it could be how many gateways are there in NRT, what's the area, so how many towers per square kilometer? And I know the topography has issues, has influence on that, a couple of other things. And the other question is, if you are in an isolated site without adjacent conservancies, and you don't have the full extent, so you're not looking at vehicles and animals and personnel, where do you make a decision as to whether to use, say, subscription-based systems like an Iridium with inReaches and a combination of digital radios versus a LoRa network? So those 2 or 3 questions I'd just like to pose to all of you, please. So.
I guess I'll start. On the first question, absolutely topography plays a part. A single gateway, a 16-channel gateway, can host up to 64,000 simultaneous connections from sensors. So I don't think any of us here are going to max out the capacity of a single gateway on connectivity. So that's not a problem. But in terms of the topography of the land, you may need to flood the area with LoRaWAN connectivity, depending on the height of the sensor that's going to be used. So what do I mean by that? If you are a person who's going to be carrying your sensors, you're about 1.5 meters. If you are an elephant, you're about 2 or 3 meters. If you are a rhino foot collar, you're about 0.1 of a meter, right? So that height affects how it communicates with the gateway. And depending on the topography will be how many gateways that you need in that area. So that can all be planned on software, and the software will actually allow you to tell, to say, I want a height of 0.1 meters, I want a height of 2 meters, put a point on the map, and it will tell you what your receive sensitivity will be. And based on that receive sensitivity, you will know whether you're going to get a good connection or not, generally. And the software is quite accurate. I would say up to now it's been about 95% accurate on its estimation. So that hopefully answers the first question. Height of the mast as well. And the height of the mast, yeah. Normally the higher the mast, the better connectivity you get, again, depending on the undulation of the ground. The second question was about using that over.
Well, also, maybe secondly, you can say how many in NRT, and you could describe the topography and the vegetation. How many sensors do you have per square kilometer? Not sensors, gateways.
Our gateways. There's 20 gateways across the landscape. We've not covered the whole landscape yet. There is a future project to do that. So, yeah.
Connected Conservation has helped with 10 projects. NRT is an exception, 20 gateways. Typically, for each reserve, we've donated about 5 gateways. And that seems to be the kind of typical, between 4 and 6, so around 5. And so I will pass back on the second question. On the second question, I think, where does it net out as a gain from a subscription model to a self-owned and self-managed model? I think it's very difficult to say that, and I know Tim's got some views on that, but you have to consider the whole park. You can't just consider LoRa on its own, because you're managing the radio networks on those towers. You're managing the internet link on those towers. It's just not always the gateway that engineer is going to service. So I'm afraid I don't have a cost structure, but I know, Tim, you've thought about this quite a bit.
Well, it's more in the extent of what you're already saying, like LoRaWAN is a communication infrastructure. So it heavily depends on how you use it. So the power of LoRaWAN is that it can have, as Swabir already gave you, like a huge amount of connections, therefore devices, per gateway. So if you are planning to, in your park monitoring, you want to have use a lot of devices, and a lot, I mean not 100 up, a lot. Then probably there will be soon a very easy calculation to be made that it's beneficial over using, for example, more expensive satellite services. So because it's a local infrastructure, yes, you have to have the cost of supporting that. It's not free, but there is like a point where it becomes more affordable. Then again, I do still think that it will always be a mix of LoRaWAN plus other connectivity standards, because there are differences. You cannot send video images over a LoRaWAN network. So therefore you need all other stuff as well. So it's not an easy to answer question, but you can make a calculation and you can make it clear.
Yeah, perhaps, Jordi, you can answer questions like in the really vast African park sites like Enedi. What do you do in those sorts of areas?
No LoRa. I wanted to actually just quickly, when people do ask you about, what are the amount of gateways you need per square kilometer, the only real answer you're going to be able to give them is say that completely depends. Because in Akagera, 1,000 square kilometers, 14 gateways. But in Bonn, Zakuma, that one gateway does more than all of the gateways in Akagera together, because it's on an insanely high mountain at an otherwise flat landscape. So in terms of really, really, really big places like Enedi, I don't really think, to be honest, at this point in time or in the future, LoRa would be a good option to cover anything like that. It's too big. Topography-wise, you've got a small amount of hills, but it's just so huge. You can't connect it with VHF either. You can't connect it with anything that is actually using radio waves easily. But yeah, if you wanted to, you could. But that is an investment that is on a completely different scale, I would think.
Yeah, I think it's also, exactly just to add what everyone said, just an example is, I don't know if some of you know Tlhahliwe Mfolozi Park in KwaZulu-Natal in South Africa. So in that area we have 16 gateways, and it's not that hilly. So, well, it is kind of more flatter area and more grasslands in some areas. So compared to Itala Game Reserve, which is a 30,000 hectare park, and it has the same amount of gateways. So, and it's very hilly. So it really, and Tlhahliwe Mfolozi Park is 90,000 and has the same amount. So, and it covers the entire park. So that's really dependent a lot on topography. We have another park like in Zanav National Park in Mozambique. the vegetation plays a bigger role. You know, you have very dense vegetation and very flat, and so you need a bit more towers there. So it really depends, as everyone has said. And I think, you know, in some of our parks, just to add what Jordi said, not all the parks require LoRaWAN, and how we look at it also from our side is that what are the threats in the park, and how many sensors do you want to add, is what Tim has also said. You know, so for instance, if you're there, Hlumimflozi Park, for instance, we all know the amount of roundup poaching carrying on there at the moment, and a lot of threats. So, you know, we have a few hundred sensors in the park, fences, you know, vehicle monitors, all sorts of animals being monitored. And that makes sense then to have LoRaWAN. You know, in other parks where there's very few threats, not many things you want to monitor, then maybe satellite might be an option. And so there's a lot of considerations to take into account. But yeah, that's a good way of looking at it.
Thank you. The other thing I wanted to ask before we open to the floor, the future of LoRaWAN. Everything is terrestrially based currently, and also we talking mainly about sending position and a couple of other bits of data one way through to the central management system. So perhaps you could talk about the future of LoRaWAN.
I think, Tim, you might know most about the future.
Well, as with any technology, it's evolving very, very fast, and specifically for LoRaWAN, which is in the space of what we call Internet of Things technologies, is also moving to space. So one of the things we've talked about is getting coverage in spaces where it's very hard to build terrestrial networks because you need towers. There are, well, two major developments as we speak, and one is LoRaWAN to space, meaning satellites will be equipped and are already, some of them are equipped with LoRa gateways, so that sensors don't connect to terrestrial towers anymore, but they connect to satellites. So then you essentially can solve some of the problems, but then still with the advantages of LoRa over other connectivities, because it remains very low power and very cheap. Another big advancement in LoRaWAN technology, which is there in the standard, is what we call relays, meaning if you have to put up a tower with a gateway, it needs to somehow be connected over a backbone or internet connection to your central server, which is part of the cost and problems of doing that. There's these relays, and the relays essentially, they receive from multiple devices the LoRa message and then pass it until it reaches a gateway, meaning adding coverage to remote areas will be way cheaper because they don't always need to be put on high locations or towers. There can be solar-powered constrained devices put on a tree or something. So there's a lot of more things, obviously, in the future, but these are the main things that also tapping into the discussions we're just having. So it's good to watch that space.
I think one thing that I have heard over the last year, what I do think is happening, I mean, Tim is already doing it and a lot of other parties as well, is that you'd have a fallback plan in terms of the sensors. So you try and send through LoRa, and if it doesn't work, there is an Iridium, obviously, there is an Iridium option, like you can have sensors nowadays that will try through LoRa. If not, you can still push it through Iridium. So that whole thing is also starting to come up, and I think that's going to be more and more as well.
It's really impossible to say the timelines for all of these. So when it's going to happen is not known. And I think what's really important is that we all work together, because what is certain is that sensors are going to keep changing. The antenna's going to need to point a different way. There's going to be new innovations that are coming out. And so what's actually really important is that we all work together to standardize that, work with the sensor community to try and get the code base and the standards in place, and keep that technology registrar going so that we can all work together to minimize everybody's effort in the community of trialing new things.
Thank you. I'm going to open it up to the floor now, so please raise your hands if you have questions.
Cool, thanks guys. So in North LoRaWAN we use a Sigfox network, which I think is being used in old Pagetta. So I'd just be interested to hear in that direct comparison sort of the pros and cons of both systems and sort of which spaces and landscapes they might be more appropriate for, from your opinions.
Well, I mean, to be very easy, I think it's the same. Sigfox is a LoRa system. I think it's a business model that's different. It would actually be, I'm not sure if there's anyone from Sigfox here at the conference, but otherwise it would be really good to hear from them. Because we've never worked with Sigfox, but the way I understand it is that it is basically a different business model in terms of you're actually paying some of the services, well, the LoRa gateway service through your sensors, right? So I think in South Africa, where you have the whole Sigfox everywhere, you can just buy a sensor and it connects, right? That's what I understand. Well, I mean, where there is a Sigfox network, you know, looking at us, well, you guys were probably lucky because you have Sigfox interested in the area and it happened. For us, I think we manage all of those areas ourselves, so you know that would not even be an option from my point of view.
Yeah, and well, on top of that, there's also a difference in the radio. So the part LoRa is different. Sensors like Ranger trackers that can software define change from LoRa to Sigfox so that you can actually use both. So yes, they're probably competing in some space, but they're trying to do the same.
I'm just curious if there's any, I know you work with a lot of different brands of sensors and you've tested a lot of different ones out, and you know, I don't know if you can mention specific brands, but are there any specific brands for LoRa sensors that you found to work the best or that you like working with the most?
I think lately Swabir has tested the most.
To answer your question, no. There's quite a few. I think the mile site sensors are doing quite good. The ones coming out of China. Sorry? Okay. The mile site sensors are doing quite good. The ones out of China. Taiwanese sensors seem to be pretty reliable. On and off, again. There's some that come out of Netherlands. Not Tim's. I must say that. But yeah, it all just depends on the manufacturer. There's some out of South Africa, so they're totally different. So it would just depend on your application and again on whether we've tested it over time or not. Yeah.
Thank you.
And then Colette as well. I think one of the things we've seen is that obviously in a lot of sensors, everyone's developing sensors, so car trackers and like Ranger trackers kind of thing. You can choose. What there is not a whole lot of yet, I believe, is LoRa in animal trackers, and more providers are adding it to their collars. But you know, I think because we also the global set ones as well actually work quite nicely. Some of the car trackers. But I think, for vehicle tracking, for these kind of assets, it's actually easy. You got a whole range of things that already works quite well. I think where the development's going to happen a lot more is in the animal side.
Yeah, just to answer that too, we've also been testing a few in peace parks, and it really depends also on what you want to do. So if you're looking for personnel trackers, we've been using range edge sensors, which is from smart parks, and so they've been working really well, and being very reliable because they can be used for different things. So that we use a lot on vehicles and for personnel trackers, and we've put some in the planes flying, so you can also see where they're going, and that's been reliable because you can use it over a suite of variety of items. And then it really depends, because some of the guys have a problem with power. So, you know, at some of these field ranger camps where we want to track people, so it might be, you know, the Abbey-Way little sensors are also being used by us, where they can just press a button on the sensor and it would go through to, you know, send an alert. But the Ranger Edge also has this facility where you can also send a message through to LoRaWAN. So there's a variety of ones that are available. Rain sensors, brilliant, a few, but we can, yeah, chat to us and we can also let you know which we have been using and which work quite well.
Thanks. Just a quick question in terms of sending your sensor sending data to your gateways. If a gateway is temporarily down, does the sensor store the data and wait for a gateway to reopen and then send it? And then sort of, you know, on top of that, are there any instances of airborne gateways sort of looking for data that it hasn't sent yet from a sensor? And is that possibly an option?
Well, the short answer to both questions is yes, but then again, just realize again, LoRaWAN is just a communication standard, as Iridium is, as Sigfox is. So this, what you're saying, just depends on the sensor. So again, you have, I think, already like 1,000 different types of sensors, and Swabir has covered most of them in his sheet. So definitely get in touch with him if you want to compare stuff. But it's good to realize LoRaWAN is just a communication standard. It's very small data packets, but therefore, and it's very low power, therefore you can have a lot of it. So with that, having said that, a sensor can be very smart or really stupid. You have sensors that are just a button. So whenever you push the button, it goes like, it's literally a 0 or a 1, goes through the LoRaWAN to EarthRanger, indicating on the map somebody pushed the button, which means there's a problem, alarm. All the way to very advanced, and I'm going to go really advanced now, we have Rhino sensors that can see what's happening based on the motion, so machine learning in the Rhino sensor, in the horn, and based on that, it's going to say, oh, there's something wrong here. And it will send a message, and then that goes to a gateway, and then to EarthRanger. So it's those type of applications you're talking about, and everything that happens in between just depends on how you configure it.
Thank you. My name is Nyasha from Zimbabwe. I don't know who I'm directing this question to, but I'm asking on a national or maybe a regional level, where how can an organization can achieve a balance between the cybersecurity aspect and also the performance of the LoRaWAN and the cost when it's designing and deploying it. This is like the infrastructure, the prices, the applications, and also ensuring that there is secure transmission after the deployment of the data and the sensitive information.
Thank you for your question. I will pass it on to the other one soon. But just to, on your last question, the security. So LoRaWAN is a communication standard. So it's being governed by the LoRaWAN Alliance. It's being used by telecom operators as well. So the short answer is you can consider it to be
network. So that's not something to worry about. So that would be your first consideration. In terms of power, you probably already have the power requirements there for running a radio network, a repeater site. it's very highly likely that that's going to have the capacity already, extra capacity, to run a LoRaWAN gateway as well, because it's very minimal power draw. So in that respect, you guys could probably achieve setting up a LoRaWAN network quite easily in terms of the infrastructure out in the park by just buying the gateways, the cabling, the infrastructure, putting that in, and then plugging it into your current pipeline that you, I'm sure, already have connecting all of these sites together. So then your only requirement would be, are you going to have a cloud server or are you going to have a static server somewhere in Zimbabwe? So, you know, those are the considerations, and that's probably how you could do it in the cheapest possible fashion. I hope that answered your question.
I just want to add that you do need to realize that because that's what we have been doing, right? Adding into radio sites, where the general coverage of LoRa is a lot smaller than your VHF. So you will find spots where you might need to add additional gateways in the future, but it is the organic way of growing is one of the ways that we've seen is actually really nice. But then you also really need to monitor what sensor is working in which. Saying that there's obviously several ways to build a LoRa system.
Yeah, I think just a good case study was, for instance, Hlubi and Pelosi Park again, where they were sponsored a lot of money to actually build these.
Radio infrastructure to better places as well. So those considerations should be taken into account. Okay.
We've got time for one more on that side.
Sorry, Brennan from Peace Parks, working on the LoRa network. Just a comment. I've really enjoyed working with the LoRa. I like it because you can see the packets coming in. You can troubleshoot. Working with other networks, you often just send it out there on a GSM network and you spend days trying to figure out if it's gone through to the GSM network, troubleshooting with the service providers. You know, the satellite providers sometimes are the same. You send it out there, can't come back to you for days. By then, your tracker's moved on to a new location. With LoRa, you log into the gateway, you can see a packet coming in, and then you can troubleshoot it quite easily before it gets to the platform, on the EarthRanger platform. So it makes it a bit easier to say, okay, well, am I actually getting the data for starters? And then you can start to troubleshoot whether it's the right data. You can see no GPS, and then maybe you're collecting other data. It might be pinging out the battery, and then you can straight away say, oh, I am getting data, I'm just not getting a GPS. The coverage must be really bad, and maybe the satellite provider's not giving it to us. And yeah, it makes it easy to troubleshoot when you have got trackers, and especially in Folosi, I think we deployed a couple of weeks ago, about 50 in vehicles. It's working really well. It was easy to maintain. We didn't have to do SIM cards, and yeah, so we've just been really enjoying working with LoRa, and it has its place, I think. Yeah, thanks.
Thanks, Brennan. Well, yeah, we've run out of time, so thanks very much, everybody. I think it was a great session, and thanks for your valued contributions. Thank you.